Hi guys, it's been a long time coming for this video, through many reasons, being late, doing stuff at work, the complicated software I'm trying to use to record this video not working properly, and having to find myself another mic in the meantime. A long combination of items because was why I'm 6 to 7 weeks late posting another video, but here we are. So today I want to go through doing a video on how to do snap to grid in Fabric.js, and this is because I'm trying to make a game at the moment that is going to require a grid system that I want to snap objects around, and I thought I'd show you how I'm going to do that. So I think we should get to that really, and we can carry on with a few more videos later. Right, so let's start. I set up a few arrays to hold some values for myself. You'll see these used in a minute, but they're here at the moment. They're all preset, so you'll have to include those. As you can see from last time, the only difference is I've made this like a white outline, removed the red square, and made a darker background, and added a header, I think. So that's the only difference. So we'll carry on from that point, I think. So first of all, what we want to do is create some lines that we're going to snap to. Well, to create a grid. So we create a for loop that allows us to do that. And then we can do, I think we'll have a 7 line grid because that's the game I'm trying to make. So, and then we will put some stuff in here that helps us create lines. Okay, so what we have here is we need to do let, first of all, let's push this dot lines y. I'm going to have 2 for loops, one for the x and one for the y lines. So this will be for y lines, and the other one will be for x lines. We're going to push a new fabric dot line. Inside of here we'll have an array, we'll fill that in a minute, and then we've got some generic settings which we are basically going to take the same ones as this square. Push. As for the line itself, we are going to want to do let y is going across. So y is going across, so what we're going to do is the y lines are going to have a differing height and top value, but the x value is going to be changing each time, but it's going to remain the same, so that's fine. So let's do it. Let L equal this dot bounding box dot left plus this dot bound box dot width divided by 7, and then we need to times that whole thing by I. Yeah, we'll times that by I. So that gets us. Why is that being angry about that? Oh, I've added an extra bracket in there. Okay, so what I'm trying to do there, the left value for the lines that I'm trying to create on the y-axis going from the top down to the bottom, they are going to have to go across the x-axis a chunk at a time. So what we need to do is divide the bounding box width by 7 because that's the grid I want to do, and then times that by the I value. So we start at 0 and go all the way across. Well, not 0, but the left-hand value of the box left. So what we should have here is a left value. So then we just got, all we got to do then is set the top and bottom value. So that t is just this dot bounding box dot top, and let sorry, I have an equals sign in there. Let b equals this dot bound box dot top plus this dot bound box dot height. So then in here what we need to do is we have left comma t comma l comma b. That should produce what we want to do. So what I'm going to do now is down here is have a let for each loop this dot lines y dot for each loop over that and create a line, and this dot canvas dot add line. So what we're trying to do here is have a separate section just for the lines, essentially, adding to the canvas. I like to keep things separate. It's just easier. So when I come back and do calculations, it's easier to test and see where things are. I know that I'm looping over the lines later on to do canvas adding stuff, and the calculations are done in a loop separated. So you might not want to do that yourself, but that's up to you guys. You can decide what you want to do there. Right, so let's go and see if that actually worked. Yeah, it did. There you go. That lines from the left to the right on the y-axis, going top down. So let's create one for the x-axis. Same thing, just x lines. This time we do a different thing. So we want to do lines x dot push. We want to do the top value is the one we want to be changing. And it's the top, and it's plus the height. And then the left value is the one we want to change entirely. So because we're going to go left to right, and then x-axis going down. So we're going, yeah. So we're going down the y-axis, but we're going. The line is from across the x-axis. Yeah. So left value, and then we need to make a R value for the right, which is going to be the top plus the width. So in this case, we do left, top, left, R, and then we do top again. So we then need to create another one of these for each loop. So we'll just have a semicolon on that to be make sure everything's going in the right direction. X. Yeah, so ooh, we've gone wrong there. What have we done? Oh, because left. Sorry, that's me. Left just needs to be left, obviously. So there we go. That. Oh, still got a problem. It's left again. Sorry, making a mistake again. So this one should be the right one. Yeah, there we go. So we got the lines coming down, lines going across. That makes us a 7x7 grid that I can then use to do some stuff with mapping a game grid out, so I can save the games automatically to a database. So let's get on to doing snap to grid now. So once we've got the grid lines in place, what I generally do is I will create a section called events, where I have my canvas events. So it's this dot canvas dot on, and we will have a object inside of here of all the events. So what we'll have is what's it, the thing called, object moved. Yeah, object moving. That's the one. Sorry, lost what it was called then. Object moving event is what we want to access today. There are lots of other events I generally use, is like selection before selection, like typography events and things like that. But today we're just going to use the object moving event. So we'll find that you can often have lots of things in here, but we only need one thing today. So what we need to do now is add a square in. So let's do this dot square equals. I had already got a square like up here, so just be aware of that. So just ready for this. So this dot square equals new fabric dot rectangle dot RECT, and then it is an object inside that, and basically we're just gonna set the top to this dot bound box dot top. We're then gonna duplicate that, and then left is the left value of the box, the big box. we're then going to go width is the bounding box dot width divided by 7, because then that's that, and then we do the same with the height. It's just that divided by 7. That should create us a object, and then we want to have controls over that, so that's fine. So what we're going to do is have the fill from up here, and we'll set that to a red for now, so it's pretty obvious what it is. Okay, so what we should have is we need to, hang on, before we go to see what's going on, is this canvas dot add this dot square. We then should see a square appear. There you go, square appears. So we have a square, but obviously at the moment it doesn't snap to any of these lines whatsoever. So we're going to create that now. So let's go back and go up into the canvas on events and go to object moving. Now we need to do, first of all, we need to do let top equal this dot closest and in here is a function I'm about to build, is array, and then we want to pass in the closest to, which will be the e dot target dot top. Okay, so this array is this dot lines lines yn is it's xn. No, yn, sorry, what am I talking about? Yeah, so top yn, we'll duplicate that, we'll have these, I'll show you what I'm going to do with the x and y ends in a minute. I shall explain. Okay, so to get, we'll come on to this function in a second. To get these values, we come into the for loop, and essentially we go this, for the y lines, we put the opposite ones in there, so we do the x, because essentially we are moving the left value each time by a chunk of 1/7. So to get all of those individual lines, y lines, their left position, we need to have, we need to store those in xn, not yn. So line xn dot push l. So I know it might seem a weird naming convention, I suppose it is, but in my head the way I'm thinking about it is we have a line that goes from top to bottom, which is going down the y-axis, so that's our y-axis line, but the left value of that line is changing. Each time we add a new line, it goes along by 1/7 of the bounding box. So I need to push those individual left values onto an array called xn that I can then target to snap to, which you'll see in a minute. So that's why I've gone with lines xn, not lines yn in there. So it's the opposite of what the line type. So the y lines get the xn and the x lines get the yn. The yn gets the top value and the xn gets the left value. So now we need to do, what we got is we got that, so we got the lines n and the lines xn. Only thing left is to build our closest function. So what I'm going to do is create a private closest function in here. So what we're going to call, we have array and then comma closest to. So inside this function we're going to have let smallest, I'll explain what this is all doing in a minute, equal math.abs closest to minus ar0. So I will explain the whole thing in a minute, so let's just get through this. And we have another value called let c equal 0. We're then going to have a for loop in here called for let I equal 0, I equal 1, I less than ar dot length, then I plus plus. then we, inside of this loop, we are going to have another value called let closest equal closest d, and because our reason why I'm naming these. Okay, so smallest d and closest d equals the same as above, but instead of 0 in the array, we're going to have the I value. Then below this, we're going to have an if statement, which is if smallest d, no, hang on, if closest d is less than smallest d, we then set smallest d equal to closest d, and we set c equal to I. Right, that's that, and then at the end we just return the C value, basically. So what's going on here is probably what you're wondering. So basically we have an array. We have an array of like individual numbers, and we have a closest to, which is the number that we are currently at. So we pass in the top value of whatever we're moving, and then it looks up against that array essentially to find the next closest value. So we start off with the smallest value being the first item in the array. Math ABS basically cancels out the minus. C is just the number that we use to target the array item, so we set that to 0. We then do a loop over the array. We then do the closest value is math.abs closest to minus the array I, so we're looping over every object in the array. And then what we're saying is if the closest d is less than the smallest d, so the current value we have at the start is less than the closest one, then we set the closest one equal to the smallest one equal to the closest one. That then means that now the smallest value is the new smallest value, essentially. And we then set c equal to I, because c represents that individual new smallest item in the array. And we return it. And then you end up with a left and top value closest to the ones that are in the array. And the array is created from the lines that are on the grid. We then do e.target set, and then we set the top equal to the top, and we set the left equal to the left, and that should be it. I think we should have a snappable grid. Oh, we're not getting the left. Okay, so we're getting, oh, there we are. Okay, I've made something wrong here. Okay, cool. Let me go and have a look at that, and I'll get back. Right, guys. The problem was me being dumb there a bit. I left this as .top. I was pretty sure the closest function was working as I was hoping. So I realised that actually I'd left this as let top when it should be left. So now we should have a working version. So there you go. Snaps the grid. That's perfect. So just my little silly mistake there. Left the left value in by mistake. So that's the best thing to do, is to always check that you're putting the right values in. But as you can see, we've done exactly what I want to do, which is make a snap to grid feature. Now, there'll be other people out there that'll probably tell you there's another easier way to do this, which there is, but it is actually dependent on the canvas, not on a line setup. Some people create a grid number at 50 feet, maybe 75 or something like that, then they divide up the entire canvas space, and you can make it a lot simpler that way. But what that doesn't give you is a specific location to start your grid from. So, for example here, I have started in the middle. If I used the simpler grid system, I wouldn't be able to follow this rule. So if you're looking for something the way you can start a grid from any point on the canvas, then this is the method I recommend, because it you won't fall foul of the other method. So to be honest, I would just stick with this method. It gives you way more flexibility. I mean, if you wanted to, you could even just not even have the lines on the canvas and just store the line values you're looking to snap to, the X and Y points. So I don't even need the grid lines really. They're just there for show for me for this specific thing. So if you're not interested in having lines on the canvas themselves, you can always just store the values and snap to them anyway. The lines are useful so you can see where your object is snapping to, so it's probably a good idea if you're trying to do this that you create some lines to start with. You can then always remove them afterwards. Yeah, that's the lesson for today, or tips, I guess, for doing a snap to grid and following me along trying to do things for my own stuff. So I'll catch up with another video, and hopefully I'll get back soon. Again, sorry for the delays in the current video making, and hope this is interesting for you. Thanks, bye.